Today, the word problems we're going to be discussing are going to be geometry-related word problems and what are called uniform motion word problems. So uniform motion word problems are going to be problems that you'll also get in physics class, but we will discuss them in algebra as well because you use math to solve them. Last week on Wednesday, that felt like a long time ago, we talked about some percent word problems. We did consecutive integer word problems where consecutive numbers added up to a certain amount. We also did word problems about some sort of age word problems. So now we're going to do some geometry ones. And we did some of those last week, like we had a rectangle problem where the perimeter added up to a certain amount. And the area was something. I'm sorry, it was about the perimeter. But we're going to be doing some different geometry problems, ones related to angle measures, and then some uniform motion. So the first thing we need to talk about are some angle measures. So one definition is complementary angles. This is spelled different than like to make a compliment. Like, oh, you look nice today. It's spelled a little differently, so make sure you spell it correctly. So complementary angles are angles that form a right angle. So notice I have two angles that come together to form a right angle. Those are called complementary. So these two angles add up to 90. So if I were to call one of the angles x degrees, what would I then call the other angle if the angles are complementary? Isabel?
No, x.
So you call it x if the two angles are equal, but you don't know that they're equal. And you could call it y, but let's say if you wanted to use not a new variable. Do you have any idea? It could be, but that would be kind of a blind guess. DJ?
X minus 90.
X minus 90. So let's say x is 30 degrees. How would you find the other one? By 90. Now, would it be x minus 90? In other words, 30 minus 90? Or?
It's the other way around.
Yeah. So this would be 90 minus x. Right? You want to put the bigger number first so you don't get a negative angle measure. So to find the angle degree that's left over, you take 90, which is what the two angles add up to, and you subtract off the x degrees. So since they add up to 90 degrees, you take 90 minus x to find the complementary angle, because they both have to add up to 90. Now supplementary angles, instead of forming a right angle or a 90-degree angle, they form a straight line. So they form a straight line, and a straight line is 180 degrees. So if I call one of these x, what would the other one be? Isaac?
180 minus x.
Good. So if two angles form a straight line, or in other words, are supplementary, one is going to be x and one is going to be 180 minus x, because they both have to add up to 180. And you can see if you add these up, do you notice how the x's would cancel? And you just get 180. And if you add these up, the x's cancel and you just get 90. Now if you have angles in a triangle, right here, this one happens to be an obtuse triangle, because one of the angles is greater than 90. What do all the angles in a triangle add up to?
180.
Yeah, these add up to 180 degrees. So because I don't know anything about the angles in the triangle, I need to introduce two variables. Sometimes I'll know, for example, that two angles are equal, then I could call two angles x. But in this case, I don't. So I'm just going to call one of them x and one of them y, for example. So x degrees and y degrees. Because when we name angle measures, at least at this point, those are in degrees. So x degrees and y degrees. And then what can I call the degree measure of this angle that I don't know? Ashley?
X plus 1.
X plus y? Now how would I account for the fact that it adds up to 180?
Would you do 180 minus X plus 1?
Good. So it's 180 minus x plus y. So you add up the two angles that you know, and you subtract that from 180, and that will give you the remaining angle measure. So these are the three different angle situations we're going to deal with. So we have supplementary angles, they add up to a straight line, or 180 degrees. Angles in a triangle that add up to 180, and then angles in a right angle that are called complementary. Any questions on that? Okay. So in geometry, we can deal with area, we can deal with perimeter, and we can deal with volume. There are other things we can also deal with, like surface area of a three-dimensional object. But here are the things we're going to focus on in this particular application section. So perimeter, we know, is the distance around the object. The area is the flat space taken up by a two-dimensional object. And volume is the space taken up by a solid. And there are a bunch of formulas in the front of your textbook that you can use to find all the volumes of various three-dimensional solids, like a sphere, a cone, a cylinder, or a rectangular solid. Areas of all sorts of two-dimensional objects, like parallelograms, trapezoids, rectangles, squares, triangles. It has the angle measures that we just went through, and then some other useful bits of information. So the front of your book is going to be useful for you in this chapter, or in this particular section, so don't forget to utilize that. So our first example is going to be a geometry example. We have the length of a rectangle is 2 feet less than triple its width. If the perimeter is 60 feet, find the dimensions. Whenever I read those things, it's like, I don't know, being a math teacher, I don't like to read a lot of words. I do for fun, but I don't love to do it in my math. So I like to draw a picture because I'm very visually oriented. So as soon as I read rectangle, I draw a rectangle. And then I start labeling things with symbols because then I can start to do math. In general, I always make the smaller side. I like to use X instead of, you could use W to represent width if you like to use the letter that represents what we're talking about, or you could use X. It just depends on your fancy, what you prefer. So if you like X, you can use X. If you like W, you can use W to represent width. But it's going to be beneficial for you to call the smaller side the variable. So I'm going to label the smaller side the variable. And then I can read the length of a rectangle. And then it says it is, so it equals 2 feet less than triple its width. So I need to write an expression for the length that represents 2 feet less than triple its width. If the width is X, what is 2 feet less than triple its width? Davian?
3x minus 2.
I wrote that wrong, I'm sorry. You said 3x minus 2? Okay, that's perfect. So the than, you say the than, it puts the 2 feet less in the back. So you do the triple its width first. So triple its width is 3x. Put this up a little bit. So the 2 feet less puts the 2 feet less in the back. Triple its width goes first, and then 2 feet less than goes at the back. So if you see the word than, that means that part goes at the back. So 2 feet less than, the minus 2 goes at the back, and then triple its width goes at the front. So that's why it's 3x minus 2. Now, when it says perimeter, that means distance around. So because it's a rectangle, I like to label all of the sides going around. So I label the opposite sides as being equal. So across from the width, those are both x, and across the length, those are both 3x minus 2. So then I have everything labeled, and so then I don't incorrectly calculate my perimeter. I account for all 4 sides of the rectangle. Then it says the perimeter is 60 feet. So I can add up all sides to find the perimeter. And so in adding up all sides, I can write x plus 3x minus 2 plus x plus 3x minus 2 equals 60. So essentially what I have done is I've added all the sides together. So the red sides and the green sides, and they equal 60. Because perimeter, again, is distance around. So whenever I see perimeter, again, I label all of the sides, because you don't want to make the mistake of only counting 2 of the 4 sides. Questions on that? What's the first step of solving then? Charlize? Okay, so which like term would you like to combine first, Charlize? Okay, so we have x, 3x, x, 3x, so how many x's, please? 8x. So 1, 2, 3, 4, 5, 6, 7, 8x. Good job. Now we have to combine -2 plus -2 is -4. Equals 60. Bringing down equals 60. Then we can add 4 to both sides. 8x equals 64. Divide by 8. And x equals 8. Now, it says find the dimensions, so the last step is always to answer the question. So the question asks you to find the dimensions. So we know the width is x, because I labeled it so. So x is 8, so the smaller dimension is 8 feet. So one little mark is the mark for feet. And then to find the length, I have to plug it into the length expression. So I do 3 times 8 minus 2. So following orders of operation, I multiply. So I get 24 minus 2 is 22. So 22 feet. So it's a 22 by 8 feet rectangle. So you have that little bit at the end, you have to calculate the length and the width of the rectangle. The width is just x, the length is 3x minus 2. Questions on that? Do I need the area? Do I need to multiply these? No, because it just said find the dimensions. But I could find the area pretty easily if I needed to. So that's a geometry problem. Again, made a lot easier in my mind by drawing that diagram and then labeling it correctly. Now we're going to do a uniform motion problem. So we have, and you don't have to write this whole thing down, but I'm going to model some note-taking for you. So the first thing you want to write down is that this is a uniform motion problem, and that rate times time equals distance is going to be the formula you use when you have a uniform motion problem. So all uniform motion problems are going to utilize this formula. So that we're just going to write down again and again. And then for this particular problem, the pertinent information is 4 hours before lunch, after lunch 5 more hours. So you can kind of write down these key pieces of information before lunch. It's 4 hours. Or maybe I should read the whole thing first. I'm sorry. My math side is taking over for seeing the big picture. So Jerry drove for 4 hours before lunch. After lunch, he drove for 5 more hours, and averaged 10 miles per hour less than he did before lunch. So maybe he just got tired. He was driving less fast, or maybe the speed limit was less. If his total distance was 472 miles, what was his average speed before lunch? And then it just has you filling that into that little box. So I have 4 hours before lunch, 5 hours after lunch. And then 10 out, so the speed was, when did he drive faster or slower? Before lunch or after lunch? Yeah, so the speed was faster before lunch, slower by 10 miles per hour. So again, if I were writing notes, I wouldn't write down the entire paragraph, because why? I mean, you could. And then it says the total distance. So that would be the shorthand for this problem. So kind of important information that I would pick from the problem. And so I would glean off, I'm looking for numbers, I'm looking for information that leads me to filling in the formula and answering the question. Now, these types of problems involve using the rate times time equals distance formula. And for me, I like using a chart to solve the problems because it helps me to organize the information. So I'm going to show you that technique now. So rate times time equals distance. So creating the chart, the first thing you do is you write the formula across the top, and then you're going to create a table. And the table is going to have 2 rows in it. And the first row is going to be the first set of circumstances. So in this case, the first set of circumstances is going to be what's happening before lunch. And then we have after lunch. And what I'm going to do is fill in 2 of the columns. Because since this is an equation, you only need 2 of the columns to find the third column. Because you only need 2 pieces of information to then find the third piece of information. So looking at the information I wrote down, I know the time before lunch was 4 hours, the time after lunch was 5 hours. So that information is given in the problem. I have to decide what I'm going to assign my x as. To decide what you're going to assign your x as, I always look at, well, what do they want to know? They want to know what the average speed before lunch is. So I'm going to say the average speed before lunch, that's the average rate. So I'm going to call that x. Okay, so I want to know what the average speed before lunch is. Speed and rate, in this case, are the same thing. So because I want to know the average speed before lunch, I'm going to call that x. Right, so I look at what is wanted, that's going to be my x. Then I look at this. Before lunch, my speed was faster. After lunch, my speed is slower by 10 miles per hour. So if my speed before lunch is x, what would my speed after lunch be? Yeah. Yeah, because it's 10 miles per hour slower. And you never, ever, ever, in this chapter at least, want to introduce another variable. So if you're starting to put y's in there, stop. Because you want to think, how could I write this with an x in terms of what we know with the problem? And now, we don't want to fill in the third column with the 472. You want to fill in the third column with the equation, okay? Because you have enough information to find the distance. Because rate times time equals distance. So x times 4 is 4x. And x times x minus 10 times 5 is 5x minus 50, if you distribute. Okay, making sure to distribute that. Any questions so far? Now, I look to the information that I wrote down. Total distance is 472 miles. Total distance. Distance before lunch plus distance after lunch is 472 miles. Okay, total distance. It doesn't say one distance or the other, it says the total distance is 472 miles. So notice I found the distance by multiplying across, because rate times time equals distance. I added those up, and I got 472. Questions on that? Nani?
You have 4x and 5x.
You will, yep. So here we get 9x. Then we're going to add 50 to both sides to isolate our x. And divide by 9.
Is that after or before?
That'd be before.
I
questions. And so, the speed before lunch is x. So this is 58. This would be 48. Because that's x minus 10. But what they want to know is what is his average speed before lunch? So that is 58 miles per hour. So he went 58 miles per hour before lunch. Questions on that? Let's do another one. Okay, so again, whenever you start seeing miles per hour, feet per second, times, distances, that's going to be a uniform motion problem. So, does anyone want to read this one? Go ahead, Charlie.
Coast to coast, Sam and Dave are driving together across the United States. On the first day, Sam averaged 64 miles per hour and Dave averaged 55 miles per hour. But Sam drove for 3 hours less than Dave. If they drove a total of 522 miles that day, then for how many hours did Sam drive? Sam drove 1 hour.
Okay. So let's set up our table. And again, in the table, I'm going to write rate times time equals distance. But in this case, instead of one person driving, we have 2 people driving. And we know how fast they were driving. Sam was driving 64, and Dave was driving 55. Sam drove for 3 hours less than Dave. And they want to know how many hours that Sam drove for. So because they're asking how many hours Sam drove for, I'm going to put Sam's time as x. You don't have to put what they're asking for as x, but if you're wondering, I don't know what to put my variable as, that's a good place to put it as what they're asking for. Okay. Then it says Sam drove for 3 hours less than Dave. If Sam drove for 3 hours less than Dave, then Dave drove for 3 hours what? More. So what would I call Dave's? Davian? Yeah. Now, the key with using the tables is as soon as you have 2 columns filled out, you don't use any other information. You just multiply across. Okay? So you have enough to find the distance now. 64 times x is 64x. 55 times x plus 3 is 55x plus 55 times 3 is 165. Okay, because you have to make sure to distribute the 3 to the 55 as well. Then I read, they drove a total of 522 miles that day. Again, that says total. It could say that Sam drove a certain amount that day or Dave drove a certain amount that day. It doesn't. It says they drove a total. So that means these add up to 522 miles. So I'm going to add those up to 522. In other words, 64x plus 55x plus 165 equals 522. So we're gonna have some like terms to combine. So I have 119x plus 165 equals 522. I'll subtract the 165 on both sides. Then I'll divide both sides by the 119x. I'm sorry, just by the 119. Is it just 3? So, how many hours did Sam drive for? Looks like Sam drove for 3 hours, because we define the hours that Sam drove, or the time that Sam drove, as X. Any questions on that? So these tables are really useful. Rate times time equals distance on the top, but again, you don't calculate distance using this piece of information. You calculate it by multiplying across, and then you use this information to write your equation. Okay, so that's a key bit to this. All right, any questions? There's your assignment.